Continuing with question number 10, a scatter plot is shown and what is the correlation? As we know, the points are going up or from left to right. So that's a positive correlation. That's it. Next. Okay, the number of solutions. We have to look here at how we can multiply these equations by a number to see if they are the same or different. Point in case, let's do the first box. We have two equations. What if we were to multiply the first equation times -2? So I would have -2 times everything, times 2x, times 2y, times 3. So that would give me, actually, let's multiply times +2. So that would give me 2 times 2 is 4x, continuing with the distributive, plus 4y is equal to 6. So that's exactly the same as the second one. So we have identity. That's going to be infinitely many solutions because it's the same equation, it's going to have the same graph. And the second one, we just have to spot it. We notice that the equation looks to be the same, but the 5y and the 7y are different. So once we have a small difference in the number of variables, then we are going to get one solution in that case. And in the case of the last one, it is the same equation with the signs inverted. So if we multiply the second equation by -1, meaning if the equation on the bottom, we only change the signs across all the equation, we can do that. That's multiplying everything times -1. -1, sorry. It's really annoying, but if we change the signs, it's going to be -2 instead of +2x. Instead of -3y, we're gonna have +3y. And then instead of -7, sorry, -7, we're gonna have 7. So that is exactly what says on the top. So it's another infinitely many solutions equation, system of equations. That's it for that. Okay, here we have to find the slope of these two functions and write another function with a slope that's in between these two slopes. So in this equation, let me go, I rise 2 and I go over 1 and I go from one point on the line to the next. So my slope here is 2/1 or just 2 for function 1. Over here, following the pattern, this one is going up by 1, while this one is going down. Sorry, going up also. Going up by 2. So the slope on the second function is 1/2. I just need to write an equation that has a slope between 1/2 and 2. So what about 1.5? That's more than 1/2, but less than 2, or even 1. So I'm just gonna write 1.5, I like, just below 2. Y equals 1.5x. I don't need a y-intercept as we're not calculating any values here, just finding the slopes. That's it. Okay. Transformations that result in figures that are similar, meaning we need a dilation but not congruent. So we're gonna choose the ones that have dilation, which are rotation translation, still congruent, reflection dilation, that's one. And that should be the only one. As I see, it's only one right answer. Correct. So that's it. Okay, let's follow the pattern. If you start from 0, then go to 4, what's your next number? 8, right? You go to 0 on the y. Go to -3, what's the next number? Well, -6. And a lot of you got this rather easily in class. Okay, the amount of money Alan earns as a plumber after so many hours. Oh, they give you the equation already. Y is equal to $25, X is hours, so $25 per hour plus a fee of 50. So what is the meaning of the 25? It means the money he makes every hour. So this is the hourly rate or the slope. So the hourly rate. The amount Alan charges per hour of plumbing, however you like it. Okay, now we go to Pythagorean theorem. We're looking for this line, which is a hypotenuse. We're looking for the line L, for which we have a right triangle that goes only halfway into B. So that little segment right there is half of 30 or 15. So let me take out the triangle outside. And I know that this is only half of B, or 15 because I go to the center, I don't go right across. Then we have the height, which is 10. And now to find the hypotenuse, we just need to use the Pythagorean theorem, which states that c squared is equal to 15 squared plus 10 squared. So c squared is equal to 225 plus 100. So c squared is equal to 325. C then is equal to the square root of 325. Can we calculate that? Can we use the radical sign to answer? Probably, most likely. We can just do this. But since we have a calculator, let's see. We have the square root of 325. And it's just about 18.03. That's what I'm gonna write. Because they do take answers that are very close as the correct answer. Let me just make sure that 15 squared is 225. I just took it for granted. So 15 to the second power is 225 plus 10 to the second power. It is 325. So my answer of 18 checks. Okay. The function y equals 3.5 to x, sorry, plus 2 is the amount of money saved over a number of weeks. What is true about the function? It is linear because the x has no exponent. So that means that the change is constant. Okay, so although it's true that it is increasing, that's not the reason why it's linear, because I could have an equation y equals negative 3.5. Somebody that's losing money, negative 3.5 x plus 2. This equation is still linear because my x has no exponents, meaning the change is constant, even though in this case it is negative. So the answer is B, not A necessarily. So B is the right answer. A cone has a height of 6.4 inches and a diameter. We just need to remember that we need to square the radius. The diameter is 6. The radius is 3, then it's half. The radius is 3. So we need to do radius squared times the height divided by 3 because it's a cone times pi, which is 3.14 divided by 3. Make sure that's a division. So let me do that in the calculator. We have it. So let's use it. Okay, so I need to do radius 3 squared times the height, which is 6.4 divided by 3. Make sure we come out to the front right here with the cursor, times pi. 3.14 is what we use. And this gives me the answer right there, 60.29. That's what I'm going to write on this box. So you have to know the formula. R squared times the height divided by 3 times pi. If it was a cylinder, we don't divide by 3. Okay. Number of solutions again, I told you about this and this identity. So that's going to be, the middle one is infinitely many solutions. The last one, the number of x's is different. We spoke about this before. I have 3 x's on the left versus 4 x's on the right. I don't need to find the solution. I just need to know that there's only one. When the number of variables is different, we have one solution always. Good thing to remember, because we don't have to do any algebra. We just do memory here. Different variables, one solution. Now, what happened on the top? We do have the same number of variables, so we know it's not one solution. It's not going to be one solution. So is it going to be infinitely many solutions? Is it identical? No. Same number of x's, but non-identical. So it's not infinitely many solutions either. It has to be no solution. Yes, when you have the same number of variables, but different constants. Here you have a 4, here you assume to have a 0. 0 will not, when we take the x's away, 0 will not be equal to 4. That is not true, meaning that 0 will never be 4, so we can never find a solution. These are on the graphs, remember, these are parallel lines that never touch. One is 4 steps higher, if you will, than the other line, but they will never cross, so they have no solution. And to end on a nice even number, this section of the review, let me remind you about the Pythagorean triplets. These are numbers that are known. We don't have to do c squared equals a squared plus b squared to know that 3, 4, and 5 work, and their multiples. Multiplying everything times 2, we have 6, 8, and 10. What are other triplets? 5, 12, and 13. And then we have many others, I believe 8, 15, and 17, but for now, this is all we need. We have the number 6, the number 8, and the number 10. Anything else does not give. We have a 5 and a 12, but do not have a 13. So we're gonna have to only select 6, 8, and 10. Okay, obviously we could have continued here with 9, 12, and 15, but that's all there is. Let us do question 21 on another video.